Okay, preparing live stream. This meeting is being live streamed. Everyone click got it.
Yep.
And okay. Cool. Let me put this link in chat. I do not have chat enabled. Okay. I'm going to WhatsApp and Twitter message you.
All right.
Okay, here we go. Twitter. Quan, don't worry about playing it. You'll get an annoying echo, but just for reference, if you want to share it on your socials, that's the link.
Yeah, cool.
Right.
Okay, and we are live. Maybe we'll just give it a minute, just see if people rock up.
I'm going to tweet this out now.
Okay, cool. Me too. And then we'll give it a couple of minutes. Okay, so I reckon we'll just go at 6:05. I reckon.
Yep. Just see how many people are on.
Good question. Okay, I got 6 people watching now. Probably includes me.
And me.
Hey, 5. Hey, we got someone on the chat. Yes. Cool. We got someone on the chat.
Good.
There we go. All right. I reckon 8. We're building up. All right. I reckon we'll start in a couple of minutes.
Okay.
Thank you for joining us for a weird and kind of wacky idea.
It's a wonderful experiment, Bobby.
Yeah.
It's a great idea. Everyone who thinks they know something about Aussie rules thinks they know who's going to win the Brownlow medal. So this is a great way of finding out whether we can do it based purely on stats or whether you've got to have some knowledge of the game.
Nobody is an expert.
No one is
Only
an
God
expert.
is. Charles Barkley always say that.
I think Charles is right. I think I've given up predicting who's going to win games of football because you just never know. You know, there's just so many variables and
Right.
you know, there's upsets every week, which just goes to show people don't know.
Hey, double digits.
Fantastic.
Ooh. See if we can get up to quadruple. I think we can get up to triple, but quadruple is maybe too ambitious, but who knows?
All right, I'll just start. Hey, so thank you everyone for joining me today on a
Hey,
weird and wacky.
Bobby.
Yep.
Somebody's got their YouTube on. I
I
need to turn that off.
don't think that's. No, I'm muted. All good. I'll just start. Hey.
Okay, might be me. All right, I'm off. Okay. Yep.
All good. All right, so thanks everyone for joining me today for a weird and wacky sort of experiment. So what I've always sort of wondered is how much domain knowledge does a sports analyst need to be successful in like prediction problems, modeling problems, all that sort of jazz. So the basic concept is let's get someone who has not watched a game of AFL, whose only real reference to AFL is a quote from Joe Ingles after watching a couple of NBA games. And if I compare them with an expert such as David Mark, how well can they together go at predicting the 2021 Brownlow medalists? So to kick things off, let's go, Dave.
Yeah, thanks, Bobby. Well, it's a really interesting experiment. I mean, at this time of the year, there's lots of predictions that come out from, who's going to win the Brownlow medal. And this year, there seems to be about 4 names that keep popping up, but the orders change depending on whose prediction you want to go through. So I won't make any names yet. But we've got Quan, new in Chicago, who's going to do the job for us. So Quan, maybe just tell us a little bit about your background.
So yeah, hi everybody. I'm Quan. Like Dave said, I'm currently in Chicago, United States right now. It's 3:06 a.m. Yeah, and I'm currently a Master of Science student in Applied Statistics at Loyola USC Chicago. And yeah, I'm just happy to be here. And like sports analytics has been one of my passion over the years because I'm a stat student and I also love sports. It sort of like combines all of my interests. And yeah, I'm just looking forward to talking to Dave and like exploring the data and learning about a new sport, which I've never watched before. So yeah, just excited to be here.
Okay, so that's a really important point. You've never seen a game of Australian rules football and you don't know what the Brownlow medal is?
No.
Okay. Well, Bobby, maybe you could help Quan.
I'll leave that to you.
Okay. I believe you've got a little excerpt you can show, just a little grab, but the game is one of the more complicated games that exist, Quan. Each team has 18 players on the field at any one time. You get 6 points if you kick a goal. You can also get another point if you kick the ball to either side of the goals. You can get 1 point. There's also another 4 players on the interchange bench that can come on at any one time. There are 18 teams in the competition. So we're getting a bit of a game now. That's the Richmond Tigers playing. It's a bit jittery. They're playing the Western Bulldogs. It's played on a very big field that can be up to about 160 or 70 metres long and sometimes about sort of 80 to 100 metres wide. It's a very fast game. There's lots of possessions. There's kicking. You can pass the ball by kicking and by handballing it, which is punching it from your hand to another player. Yeah, it's a very hard game to explain in a nutshell, but it's very popular here in Australia. We can get up to 90,000 people at a game in years other than COVID years. And yeah, it's hugely popular. And the Brownlow medal is the winner of the player who's deemed the best and fairest player of the season. And it's a very coveted medal. It's seen as the greatest honour in the game to win the Brownlow medal. That essentially you are the best player amongst the 500 or so odd players that play in the AFL every season. So that's it in a nutshell.
How does the voting process work? So I guess that's probably one of the things that need to know if we're going to model this problem.
Absolutely. So the voting for the Brownlow medal is decided by the umpires. There are 3 field umpires and they get together at the end of the game and they decide who are the best 3 players and give votes on a 3-2-1 basis. So the best player on the field out of the 44 players that have played in the game will be given 3 votes by the umpires. The next best will be given 2 votes, and the next best will be given 1 vote. At the end of the season, all those votes are tallied, and the player with the most votes is the winner of the Brownlow medal. Now, in the past 30 or so years, it's predominantly been a medal that's won by the midfielders, and that is the players who spend most of the time around the ball. Not so much the goal kickers, not so much the attackers, the forwards or the defenders, much more so the midfielders. They tend to get more possessions. They tend to be under the umpires' noses most of the time, and so they tend to be the players that get most of the votes. And you'll find if you go back over the data that Bobby's given you over the last 10 years, every single player that has won the Brownlow medal is one of those midfielders. That is a player that will get a lot of possessions, kicks and handballs. That's it in a nutshell. Do you have any questions, Quan?
No, not for now. But what really jumps out to me is the fact that the umpires got to decide these votes, because normally, the fans got to vote, right, in some sports, and even the journalists, but this is the umpires, so it's very interesting to me. So
it's a real anachronism because, of course, all season there are media competitions voting on who the best players are. At the end of the season, the players vote on their most valuable player. The coaches are making decisions. But the idea of the umpire, who's meant to be a neutral observer, deciding who is the best player, who had the most influence, I suppose, on the game, is a really interesting way of doing it. It's been argued about, whether this is a fair way of doing it, but it's a system, and we've stuck with it.
Cool. So I reckon let's just kick things off. Why don't you just share screen and let's get started with some coding.
Let's do it. All right, let's see. Share screen. There we go.
And Quan, I'm interested to know where you're starting. You've got the data for the past 10 years. What?
Right.
And you know who the Brownlow medalists are. What are you going to do first?
All right. So I'm gonna read in these packages or libraries. So here's some packages I'm gonna need later on. So tidyverse, tidy model for modeling. We'll also do Lubridate because we might need to work with dates and times. And here is the library that I'm using that Dave introduces to me, or Rob introduces to me. It's Fitzroy. Okay, then set the theme for my plot as well.
Hey, we've got Greg Buton from Stats Insider watching on, and he's one of the people that's predicted the outcome of the Brownlow medal and has his own model for predicting it.
Let's get some data. So it's Fitzroy. So let's see, what function should I use? Fitzroy. It's fetch player stats, I think. So have it on. Fetch player stats. This is the one that Rob introduced me. So let's say seasons in.
Yep. So for footy fans, Freizig is someone who contributes a lot to the Fitzroy R package and provides all the AFL data that is stored on the AFL website. So this is some pretty interesting variables that we'll have a look at modeling here. So things like contested one-on-one wins are included, which is pretty interesting.
Let's just view it for now. So data here, we have everything from 2011 up till 2021. There are about 100,000 rows and 81 columns variables. And I'm just looking at it right now. So it's all the information, the home team, the away team, the match day, the time, the scores, weather conditions, some weight and height information, jersey number, and then just a bunch of stats over here, I guess. So yeah, goals, kicks, stuff like that. Let's see what's back here.
I should point out too, Quan, just you should know too, the most important probably stats that you're looking at are kicks, marks. When you mark the ball, someone kicks it and you catch it, it's called a mark, and you have a free kick from that point. And a handball is another way of getting rid of the ball.
Yeah. All right.
So a tackle is another important statistic.
Something else, I guess, is a little bit interesting with the AFL data landscape is that data doesn't sort of get provided backwards. So sometimes when you're looking at those columns, you're seeing a lot of NAs for some of the variables. That's just because they've only recently been populated on the AFL website. So that might be something to do. It's just, I don't know, kind of just check when variables started getting recorded.
All right. Sounds good. All right.
Someone also pointed out to me that this is quite correct this year, that we had a substitute this year who would come on if a player was injured. So in fact, there were potentially 46 players in any one game, not 44.
All right. Yep. Sounds good. All right. So I think the first thing I'm going to explore is just who finished top 5 over the last 10 years, and maybe what are their total number of votes. Well, gonna need to aggregate it over year, I guess. So I'm gonna get the year from the date, because we have a year date column, so I can extract that year. 2021. Yes, let's remove it. What's that? There we go. 2021. And say group by. So we want player, maybe the ID, and set a column here. Player. So we have player ID for first name, last name. So we might need ID, just the last name, just for recognize who they are. What's the name for Brownlow? What's the name for it? Brownlow underscore votes. Okay. And also, I think this is it. This, and let's make a plot. All right. So now we have, group by, this should be here. So now we have all the total of votes for each player per season. So for each season from 2011 to 2020 last year. So now we can make a plot, I guess. So group by again, year this time. See your top 5. So I think it's order underscore by. Yep, order by. Let's see. So we want, yes, let's make year a factor. So for plotting year, and there's also like a function here where we can reorder the name. Hang on, player last name. Let's reorder in which package in tidy text, maybe go to within. So it's in tidy text. So let's load it. Text. Reorder within. Last name, total. So now we can plot it. So we want total last name, color to be here. And let's some bar plot. See, should be enough. Wrap by year, maybe 3, and let's add a layer for the total number of votes. So, and let's see what this plot looks like. 2011. Oh, need to load this. Oops. Yes, I need to change this. So scale Y reorder. And let's make it 3 columns. Okay, looks better now. Let me just change the text size as well, and then we can talk about it a little bit. Okay, so size equals 3, and maybe like an each just of 1.1.
So basically, Quan, in an extraordinarily short amount of time, you found the top 5 vote getters over the past 10 seasons.
Yes. All right. So let's look at it. So, okay. So there's some cases here where there's a tie. For example, in 2014, there are a bunch of ties here. Okay. So it's interesting. 36. All right. So seems like last year has like but between the first and the second place, there's like a huge difference. It's like 10. But the difference is like shorter, like smaller for previous years.
Last year was a bit of an anomaly too, because normally there's 20, each team plays 22 games. Last year, because of COVID, they only played 17 games. And yet Lachie Neale, who won last year with 31 votes, was a runaway winner. He was such a dominant player.
Yeah.
Easily the biggest stats getter too. So almost everyone predicted he was going to win, and he did easily.
Yeah. Because it makes sense. Because like in other sports, so was it like a shortened season as well? Like
it was a shortened season. There were 5 games less than the normal season.
Okay, yeah, because the NBA also did that in other leagues too. So it's very interesting. I already set the theme set. Make it black and white. Make it look nicer. All right. All right. So we have this plot right here. So it's a good starting point. So let's make another plot. Let's see.
So now that you've got the names, Quan, can you then extrapolate about what were some of the factors that might have caused those players to get the high votes?
Yeah, so I think I'm gonna get to that real quick. I'm gonna do a plot by position right now. So this position matter. So I think I'm gonna create a new column here. So it's either 3, 2, 1, or 0. So I'm gonna create an indicator for whether or not they got voted or not. So bells, Brownlow votes. We go to 0 to no. Yes. So indicator maybe group by. So now we're gonna do it by position. All right, summarize. Senate voted would be some voted. Yes. Divided by the total number. Player positions. Let's reorder it for plot. Position and this. So let's see which. Oh, it's not position. Player position. All right, so this is an NA. Let's get rid of the NA. So from what we see here, what does C stand for? Is that center? So C, R, and R are more likely to get voted at the end of the games. than other positions. This is from what I'm seeing. Does this make sense?
Bobby, I presume that RR is what we used to call a ruck rover.
Yep, that would be correct.
Okay, so essentially what we tend to talk about now is Quan is sort of midfielders. So there's the C, the centre, the ruck rover is another midfielder. The ruck is a player who's the tall player, like the centre in the basketball. He's the player that will take the hit outs when the ball is thrown up. Whenever there's a goal, or when the ball goes out of bounds, or when there's a stoppage, the ball is thrown up. And the ruckmen are the big guys who try to tap it down to the other midfielders. What's WL there, Bob? Would that be wing or?
Yeah, the left one. So one way to think about it, Dave, is just like an actual footy field map, like you used to get in like the record, and these positions sort of align. But midfielders might not necessarily always be centers, right? They might get named as a ruck rover or center. So
that's right. So
maybe some grouping that might make sense would help.
Yeah. So if you were to group the C's, the RRs, the WLs, and the WR, I presume, is there a WR? Or is there a right wing? Yeah.
Yeah.
Really getting the bulk of the players who play in the middle of the ground.
Yep. So I'm gonna create those grouping variables right now. So mid would be C, R, what else? WL and WR. And what else can I group? So this is a midfield, right? Is there like a defense or
if you're gonna group defenders, you would be grouping the H. Oh no, that's
so there's like HFFR and
forwards.
So that would be HBFL. So halfback flank left, a little bit down. Halfback flank right. Back pocket right. So BPR. Center half back, full back.
So FB and then BPL.
Yeah, so basically defenders are at the bottom, much to every sort of defender's dismay.
So and BPL is defender, right?
Yeah. What's BPL. RK, Bobby?
RK would be ruck. So I think it's center, ruck, rover, rover. In terms of the list. WL wing left. Full forward seem to do okay.
Yeah. So the forwards, Quan. FF, CHF,
CHF,
HFFR, HFFL, FPL, and FPR.
FPL,
FPR, FPL, and FPR. And then you've got the ruckman, who is just RK. He's a group of his own.
RK is in forward too, right?
He's not a forward. He's his own grouping.
Okay. So let's say other.
Yeah.
So, was it again?
RK.
Okay.
The ruckman.
So CRRWL, WR. Yep. FF, CHF, HFR, PFL, PFR, left and right. Okay. So this is, HBFL. Oops, B here. So HBFR for back, HBFL. What's INT?
Interchange.
Okay.
So that would be the four players that start on the interchange bench, but they can come on at any particular moment. It's not a position, so they will go into the midfield, the forward, or the back. So
so I saw in and sub here, so I can put them as like bench or whatever.
Yeah, it doesn't really give you much information because interchange players will play as much as the rest of the players in terms of game time. And you don't really know what position they go into. Normally there'll be one defender, there'll be one midfielder, there won't be one attacker and another sort of player in general. It would be better if they were included in the other positions, but that's what we've got to work with.
Yep. So now we can group it again. So mutate position group equal. So case when when case when works. Let's look at the job for this real quick. Case when. Okay, so condition 1, if player position is in the mid, then midfield. If player position is in depth, then defense. If player position is in forward, then forward, and our case other. And bench. Oops, bench would be correct syntax. Player position is in bench, then just call it bench. Character position, player position. So yeah, I think we can copy everything. This time we're doing position group instead of player position. See if we have everything. Mid, not I'll need to run these. All right,
There
so
you go.
yep, so midfield tends to have lots of votes. Other is just one category, so
You'd be better to call that category ruck, because that's what it is.
so ruck is it as in RU
CK.
Oh yeah, okay. So we're midfield ruck, forward defense. Ooh, forgot to group these. So where does these two belong? CHB is for backs, right? So defense.
CHB is defense, yep.
Yep, and also
BPR is defense.
yep, BPR. All right, there we go. Cool. So midfield, ruck, forward defense, and bench. So midfield could be a significant predictor here. So if they, play in the midfield position, then might have a high chance of winning the vote. So
if you go back to your winners, the top 5 for the past 10 years.
Okay.
I can tell you in every season. So 2011, they were all midfielders.
Yep. Let's see. All right. Zoom in.
2012, they're all midfielders. 2013, all midfielders. 2014, all midfielders. 2015, all midfielders. 2016, they're all midfielders. 2017, all midfielders except for Franklin, who's a forward. I presume that's Josh Kennedy, the Swans player, not the West Coast player, Bob. Not sure. 2018, all midfielders except for Gorn, who's a ruck. 2019, all midfielders, and 2020, all midfielders.
Wow. So they're dominating. The midfielders are dominating this award.
Absolutely.
Yep. Is it fair to say that this league is a midfielder league? Because, like I think in the NBA, it's not like a guard league where they control everything. They shoot all the time. So is that true to say that this is like a midfielder dominated league or something?
It's a competition where the midfielders will get most of the possessions.
Okay.
And they will score a certain percentage of the goals, but it's not just a midfielder's game. You need a very good defense and you need a good forward line.
Yeah.
What tends to happen is because it's the umpires who are making the decisions, the midfielders are the ones who tend to get most of the possessions, kicks and handballs, and they're also under the umpires' noses. And so the umpires will be more aware of them because they see them get, a good. It's a good game if you get sort of 30 possessions. A forward might kick 6 goals, but they might do that with just 10 possessions. And 6 goals is a lot of goals now. Generally 3, 4, or 5 is considered a lot of goals in a game. So it tends to be the midfielders who get most of the possessions, and those possessions tend to correlate with Brownlow votes.
All right, sounds good. All right, I just got an idea of a data visualization. So let's see if I can pull this up. I'm gonna make a heat map, which shows week by week votes for every winner. So we're gonna have one for 2011 up to 2020. It's gonna span all the weeks of the league for every year. So let's see. So I think I'm gonna rename something here. I'm gonna use this table up here. So aggregated votes. This is a good stopping point. So I'm gonna use this table. All right, just to get the same graph. Good. All right, aggregated votes. So the heat map. So we have aggregated votes. Let's see. We're gonna get the winner. We're gonna get the names of the winners here. So let's see. So group by size max. Get them. The one that has the maximum number of votes, followed by total, and ungroup. We don't really want the total here. We just care about the name because we're going to join it with another table. This is how I would do it. So Swan, Watson, Ablett, Pritis, 5, Dangerfield, Martin, Mitchell, 5, and Neil. So 5 won it twice over the past 10 years. Other than that, everyone won it once. So it's good to know. And 5 also finished in like the top 2 this year. Very interesting. And Swan is like, so from 2011, 2013, he's in the top 5 for every year. But since then, he never made it. All right. So anyway, so let's make a heat map. See if we can pull this off. So let's call this.
What sort of heat map do you want to see?
So I want to see week by week votes for the winners. So we're gonna color code it each week by a color. So it's either gonna be 3, 2, 1, or 0. So let's see if I can pull this off. Let's see. NFL. I don't think I have the year here. There, let's do it again. Year, match date, inner join with winner. What's the variable name for the week?
You probably want to take round number.
Yes.
So, and then you want to filter out for finals because Brownlow votes don't get awarded in finals.
Got it. So filter out finals. So unique AFL. Is it match round? So all the finals has like, okay.
Yeah, so this is just an award for the home and away season, kind of like the NBA MVP. Finals don't count.
So remove all the finals. So match round, final, just a straight final here. Oops. All right, so remove final and then convert round to numeric, applying. see. So that's all I have to do. Let's see. Axis would be year, and field would be the brown. Is it Brownlow? But it's okay. Oops. Numeric. Misspell it. Oops. There should be a plus here. All right, so I'm gonna make it look a little bit nicer and more readable. So change the axis a little bit. So scale Y breaks 2011, 2020. Scale X. So it's like 1 to 24. And color brewer for this. What is it? Palette. Let's do purple orange. Theme. Make it minimal. Also get rid of all the panel axes. So theme panel grid. Major elements blank. Grid dot minor element blank. And also let's move the legend down to the bottom. So legend. Title. Don't really need the names here. It's gonna be Brownlow. All right, so let's see. This is a nice little heat map. So what jumps out to me, the first thing that jumped out to me is like in 2011, there are more browns than some of the years later on. Is that true, Dave?
There might have been, I don't know what's going on there. Each year there are 3 weeks where there is a bye.
Okay, so it's like a bye week. Okay.
Yeah, but
the other thing is this is a plot only of the top vote getters, right? So
Yeah.
it might also just imply that for some games, like they were just had a bye, so they didn't get any votes, right?
Yeah,
right.
Yeah, that's a blanks here. Yeah. So yeah, so like you said, 2020, the guy dominated the vote. So he got a lot of 3 here. Yep. And let's see what's an interesting pattern here. Because I mean, they needed lots of 3 in order to win. In 2014, this guy only has 4 games with 3s, but also a lot of 2 and 1s. So that add up pretty nice.
Yeah, that was Maddie Pritis. Good,
okay.
Good Brownlow medalist.
Good. All right. So yeah, so that's just my idea. That this thing just jumped out to me like 5 minutes ago. So I just wanted to make it so.
So it's actually really interesting that you've decided to do this, because one of the key factors is into winning.
I just wanted to do some visualization. So
yeah. Well, no. One of the things, I mean, we've got Greg from Stats Insider. I don't know if he's still on, but one of the things that he factors in and says is very important, and so do others, is it's obviously very important to get as many 3 votes as possible.
Yeah.
And you've sort of picked that up. Consistency is obviously really important, but it's obviously better to get 3 votes than 1. So the more 3 votes you can pick up, the better.
Yep.
And so thus far, you've picked up on things that we already know here in Australia, which is a midfielder will always win the Brownlow medal.
Okay.
As I said, I think in the past 29 seasons, there's only been 1 player who's won it who hasn't been a midfielder. So we can be almost certain that it's going to be a midfielder. And the other fact that you picked up on that is really important is the number of 3 votes and the consistency of getting votes.
All right. Yep. Yes. So I think this guy, because there's like 1, 2, 3, 4, 5 missing, and you said there are 3 bye weeks, right?
It could be that the
So
player didn't play that week.
Yeah, he might got injured, or
Yeah.
Is like player resting a huge thing in this league? Because I know that for the NBA or the NFL, during like later weeks, if the team's like already clinched the playoffs, then they like might rest some players to protect them. So it's like a huge thing in Australian football.
It definitely happens. This season, not so much, because a lot of the teams were still playing for finals positions and playing for the best position in the final.
Okay.
It's better if you finish in the top 2 and then the top 4. Ideally, you want to get to the top 4, and ideally, you want to get to the top 2, but also other teams vying to get into the 8. So it's the top 8 teams that contest the finals out of the 18 teams. It was a very close competition this year, so there wasn't a lot of resting, but there was a little bit. But a player might miss 1 or 2 games at most in the season from being rested. If they miss other games, it's generally because they've been injured or they've been suspended for a week or 2 because of some infraction.
Sounds good. All right, so I think about 45 minutes has gone by. So I think we can get started on the modeling just to make sure we have something at the end so that we can see if I can make some predictions here. So let's actually get started on the modeling now. So modeling. I think I have the packages here.
I'll go and get a beer while you get started on that. And if you need, do you have any questions actually before you get started on what might be some of the key variables?
Yes, exactly. So you mentioned before, I have it right here. So kicks, marks, and tackles.
Yeah, I've also taken some requests from the YouTube feed. People have suggested disposals, goals,
the other
contested possessions, meters gained, disposal efficiency, margin, so whether they played on the winning team or not, are some of the suggestions that have floated through.
Okay.
So
all right,
with disposal, that will cover kicks and handballs, which you didn't have there, Quan.
So have kicks right here. It's a handball.
Handball, yeah, you've already got kicks. So
yeah.
disposals, kicks and handballs are both considered disposals, but then you'll probably find them as a separate grouping in the data, I would say. Is that the case, Bobby?
Yeah.
All right. So so I can get this set up and we should be able to roll. All right.
So I'll get a beer.
All right.
I already have a beer.
All right. So stats. Yeah, I think I'm just gonna use data from the past 5 seasons for now. We can go back and change it, but let's see. So filter match round. So we only want, so it's like 1, 2. Character 1, 2. 22, 23, 24. Okay, let's make it 24. And so we're going to select all of these. Let's see here. So let's inspect the data real quick. This is the original. Okay. So kicks, marks, handball. We're going to put them in order here. Kicks, marks, handball, disposal, and effective disposal.
Yeah, they're not always, they haven't been recorded for that long, unfortunately.
Yeah. So I guess we could impute them. Yeah. So disposal. So did the chat want me to use like all 3 or just disposal? Can you repeat?
Just disposals. I think we'll be all right for now.
Okay.
Yeah.
Disposal. Goals. And so from what I have here is tackles. Let's see. So contested possessions.
I think you might be doubling up if you have kicks, marks, and handballs. Sorry, kicks, handballs, and disposals.
Okay.
Because a disposal is either a kick or a handball.
Okay. So let's see. What should I get rid of? So
you could either make a grouping of disposals, including kicks and handballs, or keep them separate. Kicks are generally seen as a bit more important.
Yeah,
so you can get more distance, but not always.
Yeah, kicks. So I'm gonna use kicks and handball. So yeah. So disposal, tackles, and contested possessions. Okay. How do they determine whether or not it's contested or uncontested is my question.
Okay, so a contested possession is basically in any situation where when you've got more than one player, you've got two players, so at least two players, one from either team, fighting to get the ball.
Okay.
If there's a situation where, say, there's a lot of players around the ball, but somebody manages to win the ball, that's considered a contested possession. An uncontested possession is when it might be an easy mark or the ball is in the clear, there's no one else around.
Okay. Yep. Meter gains. I think that's all. And I'm also going to create a variable for game results. I think I'm forgetting margin as well. So game result is just whether or not a team win or lose, because that should be a big factor too. All right. So margin, let's see if it's fine whether or not there's a margin here. Match margin.
Yeah, so you got to create it in a bit of a weird way. So there's match margin, which will always be positive, and then there's match winner.
Yeah.
So you kind of have to go where player team is equal to match winner.
Yeah, got it.
Then yeah, sweet.
Game outcome. Third team. What's the name of it before? Winning team. Match winner. Okay. That would be win. All right, and check.
Somebody watching on YouTube has also suggested clearances. Have we got that in there?
Clearances. Okay. We can add it.
So clearance is essentially when you've got a lot of players around the ball, there's a pack, and one player manages to extract the ball.
Yeah. All right. So just the data. Let's select all of these. Also match margin clearances.
So Quan, could you apply these retrospectively over the previous Brownlow medals to see which has been the most important of those variables?
Yes. I'm going to do that right after I finish setting this up. So clearances, margin, and game outcome. All right. Okay. We might need some. Do we need some IDs here? Keep some ID for some prediction later on. Also the date, some filtering, player ID, maybe player last name. That's all. Let's try it. Okay, so looks like we got a data frame here. Okay.
Don't forget the votes.
Oh, that's right. So that's the response variable, right? Brownlow votes. So I guess we can start setting this up. So train data set would be for the year, not 2021. Don't mutate anything. Yes, factor Brownlow. That's the factor Brown votes. And yeah. That's the filter. This is AFL Pret. Year. Match date. 2021. Yeah, that's it. So this is gonna be a holdout set. Use this for prediction. Predictions. This is gonna be training data. Gonna all right, so let's set up the cross validation. So splits. What's the name for this train? Yeah, we're splitting the train. So then we're gonna have a training within the train. Training. Then validation. This is the validation data. The testing. And validation here. Fold it and make it just do it 5 folds for now.
I would love to know what all this means.
Yeah. So I can explain the process.
It's witchcraft as far as I'm concerned.
Yeah. So like I said over here, so we have all the data, right? And we want to predict 2021. We're gonna hold the set out and we're gonna use for predictions. So we're not gonna touch on it until we're done. So and then we have a training data. So this is all the years before 2021. So for this train data, we're gonna split it into 3 different parts, or actually only 2. We're gonna have like a training data set where we're gonna use it to build the model and a validation set to validate the model. So I'm gonna do some tuning along the line. So along the way, so we're gonna use that to select basically the best model and then try to make some predictions. So.
Okay, so you're trying to find out what are those variables that you've highlighted, kicks, marks, handballs, goals, etc., seem to be the most important in predicting the Brownlow medals in previous years.
Yeah. We're gonna get that too. Yeah, we're gonna get a variables important plot at the end, and we're also gonna see how much of a significant those variables are, and also we're gonna have of course some predictions. Like what is what does our model predict for the total number of Brownlow votes that each one of those players should get. Okay. All right, so let's create a model here. Do an XG boost. XG boost stands for extreme gradient boosting, which is a very popular machine learning algorithm nowadays. So let's create a specification. Bruce tree. Let's look at the doc real quick. Tree. Tree. Okay, so you can set the mode here. Okay, so mode would be engine XG boost. Then we're going to tune. So M try is going to be tune. Try to select the best select predictors and try, and also
Can you explain for the layperson me what tune means? You say
So-
you saw tuning about a few times.
So tuning means we're gonna have like a bunch of let's say values for these parameters for the model. And we're gonna do sort of like a grid search. We're gonna plot it and we're gonna see which combination of these parameters give like that minimize some loss function that we're trying to use. A loss function means we can use a loss function or accuracy. So which basically how well does the model predict this? Yeah, the data. So
Okay.
yep. So I think I'm gonna also set the learn rate set as 0.2 for now. So it's a specification, and we can also get a recipe. So it's recipe. Recipe. I don't know how to spell. Okay. Recipe. So the response is going to be Brownlow votes for now. And the predictor is going to be everything. And we have data equals name it AFL train. Then we're going to remove these columns because we're not going to use them. We're just going to use them at the end for some information identification. So we don't need them in the model. Remove. So I have game results here, game outcome here. Let's turn it into an indicator, a dummy variable. Also do like a mean. Let's do median impute. So missing values. I don't think we need this because we only have like 16 columns, and let's be sure step is it NCV. Let's look this up. NCV is it CV? CV is for. I don't think this will be an issue. So yeah, we don't really need this. Okay, so we have a recipe. If I train, haven't run it yet. Oops. Recipe. Okay, so now we can create the model. So XG workflow would be workflow space here. I'm going to add the model in the recipe. Right. All right, so we're going to tune right now. So XG tune would be XG workflow. I'm going to create a grid. Tune grid. Sample is going to be, I'm going to name it cross validation. So if underscore CV. Okay, so the metrics would be metric set log loss. Control would be control grid. I would say prediction. Save thread. Save workflow. Well, not too worried about that. Grid. We're gonna do a a Cartesian product here. So M try, yeah. So I have M try and 3. So M try would be, let's try 3 to 6. These would be, let's make it so it go from 200 to 800 and by 50. And before I tune, let's also set up some parallel computing. It should be parallel, speed up the computing process. Hopefully I get everything right. So let's see.
We're relying on you, Quan.
All right, so while it's running, I'm gonna also set up another model where in this case, I'm gonna use all of the statistics. Let's try it. Hit boost. I have a template set up for this. So cat boost as well. I'm not
You
going to tune this model.
you said while it's running, how long would it take to run this model that you just?
We will see. Normally, well, for this data, it's not going to take long, I don't think, but it's normally, it really depends on how much data we have and like how, and also how the variables we have, and also how many parameters are we looking at. So it's yeah. So time's like a function of like all of those variables, like how many columns, how many rows, and how many parameters. All right, so cat boost. So installs the what are they? So lubricate and fits. How do I spell it? It's short. Okay, cool. Oop. This should be concatenate. And don't need tiny models here. So cat boost. All right. This is still running. Let's wait for this so we can set it up, I guess. So if that would be fetch place that. So I'm going to copy all of this. So yeah, 2015, 2021, match round, match margin, game outcome. See what do we want to select? Cool, so it's done. So now let's run this. Select.
Got a few requests in the YouTube chat. They're just asking, can you please save your script because they want to give it a go, but you're going like a maniac.
Yeah, definitely. Yeah, I'm gonna make it available on GitHub. So yeah. All right. So
Someone's also asked what the this cat boost thing is.
So cat boost is an algorithm for machine learning. So here for this model in here, I'm using an XGBoost, which is another algorithm, and cat boost is like a pretty new algorithm, which it's used a lot for supervised learning, so classification and regression, and it tends to give like pretty good predictions from my own experience. So this is one of my favorite things to use. So we will see if this will turn out. So let's see which concept I want to select. So just for now.
So if you get different answers from your two different algorithms, what's that going to tell you?
Like, I mean, if one is consistent with like the norm, like what people expected, like if I give like, then yeah, I don't know, but they should be consistent. I think they should be consistent, because if I'm using like the same like type predictors and the same set of data, then it shouldn't be that much different. So that's my guess. Glimpse this, glimpse AFL. All right, so I want all of the statistics. So basically from kicks down to spoils. I'm going to do this with an XG boost too. Once this first model is done, I'm going to go back and do this again. Maybe position and outcome.
What are you making of this, Bobby? Are you as amazed as I am?
Yeah, I'm pretty amazed at the speed he's going at. But also, like, I think one of the cool things about sort of, what he's doing with R is how quickly he can get up quite advanced sort of models pretty quickly. And he's certainly not wasting any time switching from R Studio to work on his next little prediction for everyone.
So train. Select. Yeah, so get rid of manage date.
So the fascinating thing about this is if Quan gets it right, and we'll find out on Sunday night, Australian time, we could potentially just do away with the umpires' votes altogether. Just apply the model.
Yeah, but then I don't know how Razor would take that. I think that's sort of like the highlight of his umpiring, surely.
And so, Quan, you'd be interested to know too that I spoke to Greg from Stats Insider. I'm not sure if Greg is still with us, but one of the things that he does on his model is he uses the stats, but he also uses the votes that come in throughout the year through the media votes, coaches association votes, and so on. And he says the weighting is about 75% on the media voting and the coaches' votes and about 25% on the stats. He thinks that the human element of having people watching the game and judging the game is a really important factor. That just doing it on stats alone won't necessarily get you the answer. So that's something that you don't have, and that's why this is such an interesting experiment.
Yep. Oops, should be test. Name it wrong. All right, I think we're done here. Let's see if this is going to give us anything. If not, we will fix it. All right, so let's look at XG tune and just a quick plot here. You see, okay, interesting here. Sitting accuracy and ROCAUC. Seems like this one right here gives us the best prediction, which is 3 and then 500 trees. So let's get that. Like metrics. And
so before the list comes out, David, based on that list of variables used first, who do you think will come out top in this first cut of a model? Or the YouTube cut, as it were?
Sorry, Bob, are you asking me who I think is going to win the Brownlow?
No, who do you think will come out in this first cut of a model that we're seeing here?
So what players?
Yeah, so this was the one that was taken just variables from YouTube. So kicks, handballs, clearances, contested possessions.
So we'd expect to see players like Jack McRae, Oliver Wines, Clayton Oliver, Christian Petracca. Those are some of the big, Jack Steele from St Kilda. Those are some of the names. They've been the big possession winners. So I'm expecting to see the big possession winners.
Yeah.
Um,
Some people in the chat, I reckon it'll be Clayton Oliver. Seems to be one of the more popular players, or Ollie Wines also seems to be pretty popular.
Yep.
As the
Darcy
first card.
Parish, we'd expect sort of Darcy Parish to be thereabouts, Rory Laird as well.
All right, so here is a very most important plot. So according to our model, the YouTube chat model, goals, and then kicks, and then contested possessions. Those are like the top three variables with the most contribution to the prediction. And then we have handball, meters gain, match margin, clearances, marks, tackles, and game outcome. So this is what our model gave us for the variables important. So goals and kicks are the two most important. Does that make sense? Does that make any sense, Dave? Because you have to score goals, right? And kicks is the point after the goal. So
yes and no. I mean, you might get a player kicking 3 or 4 goals out of 12, but that doesn't necessarily mean he's been the most influential player, the best on ground. So that's interesting. I mean, if you get a midfielder who gets a lot of kicks and handballs and kicks a goal or two, that will definitely add to that'll definitely add to it. The umpire will look favourably upon that. I think for a forward to kick a lot of goals and get the votes is rare. It can happen, but I think it's when you get the combination, that's where you get the sweet spot.
okay, yep. So now I'm gonna make some predictions here. So let's see if this makes any sense. Fit it to train model.
The interesting thing too about the awarding of the votes is we don't know whether the umpires look at stats, but suspect that they don't. They make a decision after the game.
Yeah.
Consultation between the three of them. So they don't necessarily know what the stats are. So they're basing it on their gut instinct. Yep. It just seems from the past however many years or so that being a midfielder and getting a lot of the ball, so winning a lot of disposals, seems to be the overwhelming factor in predicting in the winner as well. Yeah.
Okay. Did I name something here? Oh, there we go. Let's try it again. All right. Let's see if I can set this up too. So I have this. So let's do some cat boost. Y train. X train, B train. No votes. No, all the predictions. X. For a cat boost dot low dot pool. That's pool. Fit it. Train. What's it called? Train pool. Yeah, train pool. And I'm gonna all default parameters. I'm not going to change anything. I'm just going to change the loss function into a multi-class. This looks right. If not, we'll see. Oops. Loss function. Oh, it's 1 equals sign. All right, it's running. So it's all right. All right. So we have some prediction here. So let's see who wins according to this model. All right. Let's see, what do I want to do here? I want to just get the player names and the predicted probabilities. So select, what are the names here? So player first name, okay. So basically contains name. Also contain predictions here. So dot pred. There we go. Mutate. Selected pose would be so 0 times that plus 1 times dot pred 1 plus 2 times pred 2 and 3 times dot pred 3. Group by, so it's first name, total votes would be just the sum of range it by. All right, so there we go. So according to our model, we predicted that Clayton Oliver will be the first place or the winner with roughly 30 votes. And then Christian Petrarca will be second with 26.1, followed by Jack McRae, 25.8, so about 26. Marcus Bontempelli, about 24. Ollie Wines, 23, and so on. So David, is this make any sense? Does this make any sense, or
it's extraordinary? That's absolutely extraordinary. And the reason I say that is because those names are all pretty much the names that most of the sort of the pundits and the models are predicting. And what's really interesting too, though, is that of those top 4, 2 of them play on the same side. They're also both, they're all 4 of them playing the grand final. So they're clearly from the best 2 with the grand finals in a week. So they're clearly from the best 2 teams. So Clayton Oliver and Christian Petrarca both play for Melbourne. Jack McRae and Marcus Bontempelli both play for the Bulldogs. What's tricky about having players from the same team is that they're potentially taking votes away from each other. So every time Clayton Oliver gets 3 votes, that's 3 votes that Christian Petrarca can't get. Right. Same with McRae and Bontempelli. So that is a factor worth considering. A lot of the models have got Ollie Wines winning, that you've got in there. Darcy Parish had a fantastic year, and in some awards that were given on the day, he won, awards on the day for being the best player in particular games a number of times. Jared Lyons had a really fantastic and consistent year. Jack Steele, who you've got at 8, was an absolutely standout player too, and a lot of the predictions and models have him thereabouts too. If you I was looking today at about 7 or 8 different sort of media awards and predictions and so on. Okay. The names that keep coming up are Clayton Oliver, Marcus Bontempelli, Oliver Wines, and Jack Steele. Okay. Jack McRae comes up in some models, but he's really down in other models. He was overwhelmingly the largest possession getter of the year. I think he was 800 and something, and he was about 80 ahead of the next best, who was Ollie Wines, who had 777 possessions. But, it's interesting that Stats Insider give him less than I think a 0.1% chance of winning because they didn't think he won enough 3 votes over the course of the competition. But he was a brilliant player. Took Miller, you've got there too. He had a really great year. He's ineligible for the Brownlow medal. It's the best and fairest award. And if you've been suspended for the year for some kind of wrongdoing, then you can't win the award. You're not going to get the fairest. But all those players are all the players that are very much in the conversation. And you could be, almost 100% certain that one of those guys will win it. So you've done exceptionally well thus far.
Yes, so I'm going to try to do it again, but this I'm going to use more predictors. So I'm going to use all the stats for the XG boost. Meanwhile, we're going to check on the cat boost. So this is basically cat boost with no tuning, just default parameters. Hopefully this will be boost predict it as pool and then prediction type. Really, and let's run this. So just need to append this to a matrix. So this is a matrix that's converted to a table. Table. And also name to 0 vote 1, 2, and 3. So that's fine. So now we have to append that to the test data. All right. We need to get the last name. So I don't think I have it. Yeah, so I have to, let's get the last name. Just do this real quick. Forgot to do this. So players names 21. Just players 21. Get this for 2021. Filter match round again. So now get Preds again. That so players would be player B, player 2021. That's yep, so we got the right dimension here. Okay, good. And it's also calculation. So that's it. 2 times v2 plus 3 times v2. And then sum them up.
So I don't know, maybe you want to consider also taking player ID. Just there are some players that are popular vote getters that share last names.
Okay. Expected total votes. Minus. Then let's look at the top 10. So let's see. Oops. Something's wrong here. Oops, it should be EXP. Look. All right, so wow, this is kind of high. So according to Cat Boost, Oliver's 1, Petrarca's 2, McRae's 3rd, Wines is 4th. But notice that the expected total votes is kind of high. Yeah. So again, this is just a stock model with no training. So yeah, so this might be, so we might need some tuning to do. But again, we still got Oliver as the winner. Top 4, Petrarca, McRae, Wines, Kelly, Leons. Montpellier is slow here. I think he was like 2nd or 3rd.
Yeah.
Or 4th in the previous model.
Kelly's an unusual name in that one too, because he really doesn't figure in any. He didn't figure in your other list, and he also doesn't figure in any of the lists that have been compiled by the models and the media voting.
Yeah. All right. So now, let's go back to XG Boost, and I'm gonna build another model. So,
what are your thoughts now, though? What are you beginning to think that you might need to refine?
So I'm gonna add more data for sure. I'm gonna use, instead of 2015, I'm gonna put 2011. Kind of add more predictors, of course. So let's see. Let's keep all of these. These should be all in here. So match ID, my last
I'm
name.
interested to know if you can go backwards, if it's worth your while to know what are the values or the variables in previous years that might have had an influence on the winners, or if that's not something you want to do.
So previous year, because we use all the data from previous year to train the model. So if we predict there's going to be some, like, I guess, overlap, is that the right word? Or so let's try kick to spoils. Okay. So all of these, then kick to spoil, and then margin, player, position, and game outcome. Yeah. All of these. Yeah, that's fine. Okay, hope this is right. So, new model. Here we go.
Have you got some coffee there, Quan? What's keeping you going? It's like 3 o'clock in the morning.
I don't drink coffee. I drink water. So,
okay.
I mean,
because it's 3 o'clock in the morning in Chicago, right?
Yeah, 4:30 now. But
okay.
Yeah, but
you're doing well.
Yeah, I'm doing very well. All right, so Brownlow votes. Back to that, yeah. That, and now tests. So let's look at the tests real quick. So we have a bunch of variables here. Super coach underscore score. It's all NAs. So we probably have to get rid of this column because it's all missing value here. Super coach. Oh no, it's tests. Doing a quick check. Super. Yeah, it's equal to the dimension, so everything is missing here. So we don't have this column here. So let's get rid of it. Select. Filter out the votes because that's what we want to predict. So I think it's all zeros now. It hasn't been casted yet. So yeah. All right. So let's also get rid of that. Oops. Something pops up. Score. Okay, I think that's all I need to change. Then I'm gonna keep everything the same and tune the model again. All right.
Just while you're doing that, I might. I was going through some of the models and predictors today. So, Champion Data, which provides data to the AFL, has got Clayton Oliver winning it.
All right.
Marcus Bontempelli second and Christian Petrarca third. This is in no order, okay? The AFL Coaches Association has got Clayton Oliver winning it from Marcus Bontempelli and Ollie Wines. ESPN in Australia has got Ollie Wines winning it from Clayton Oliver and Jack Steele. The ABC Footballer of the Year, I've got to promote the ABC because I work for the ABC. They do the 3-2-1 votes. They've got Clayton Oliver winning it from Oliver Wines and Marcus Bontempelli. And Stats Insider, I believe, actually I should say the AFL, we've got the AFL, they make a predictor too. They've got Clayton Oliver winning it from Marcus Bontempelli and Jack Steele. And Stats Insider, they don't really predict a winner, they predict odds. So they've got Oliver Wines at 34.9%, Marcus Bontempelli at 23.3%, Clayton Oliver at 23.1%, and Jack Steele at 16.4%. And then it drops away. And I mentioned before that you had, they've got Jack McRae really low at less than 0.1%. Even though they predict he'll win 15 votes, they don't see a universe, in Greg's words, where he'll actually win the whole thing.
Okay. Very interesting. All right. So let's let this run. It should take less than 5 minutes. Or maybe not. We'll see. More like 7. We'll try. All right. I'm going to go get some water and I will be right back.
So, Dave, what do you reckon so far? So I guess this would be the first time you've seen this sort of done live.
Yeah, it's absolutely amazing. I can't believe how quickly Quan got all the data up from the previous years and was able to draw some conclusions from it. Like, it's stuff that we know, right? Because we know who wins the Brownlow medal and we know that it's a midfielder's award and so on. But the fact that he was able to distill and filter that data so quickly and come up with that same conclusion without any empirical knowledge, it was just based on the data, was extraordinary. And then to see him come up with that list of names, which so closely marries, you know, the predictors, the prediction models that we've seen so far and the media votes and the coaches' votes and so on, it's really extraordinary. So what I'm really interested to know now is how he's going to refine it even further.
Yeah, well, I guess watching this, he's definitely got the bulk of the work out of the way. So now it's just, yeah, like you were saying, he can just pick some different variables, maybe create some different variables and just kind of hit run and see which lists keep popping up.
And maybe you could explain for me, and I know most of the people watching will know what's going on, but I don't. He's using machine learning. How is he training this model? Like, what is machine learning and how can he train the model to sort of learn as it goes?
Yeah, so I guess I'll let him do it because it's sort of his model, but I find it pretty incredible just like how quickly he's actually churned through all these different models personally. But yeah, I guess I'll let him, because it's his work, explain sort of like the little intricacies. But yeah, I'm really impressed at how quickly he's actually gone, because I think we was thinking in my head when I first thought of this idea, I was thinking, oh yeah, maybe he'll get out a prediction just before 9, right? But I mean, we've got like an hour 20 to spare.
And he spent the first 45 minutes just going over the previous data.
Yeah.
So yeah, Quan, we're just singing your praises. I'm just really interested to know, you mentioned machine learning. What is it that you're doing in terms of, like, how is it that the model that you're creating is actually learning as it goes? Is that the case?
Yeah. So the model that I'm using is an XGBoost, which stands for extreme gradient boosting. So I mean, first of all, so the purpose of machine learning is to make predictions, right? So we input the data and it will give us some predictions. And this is a classification problem where you have, the outcome, the target variable is the Brownlow medals, those are the votes. So it's either 0, 1, 2, or 3. So that's we have a multi-class response. And what this model does is that, again, I'm not like an expert in like knowing what's like deep inside the model, but it's a boosted tree algorithm where I might be a little bit technical here, but
Go for it.
They I think they use some sort of optimization methods to like optimize everything inside of it. So like all of these parameters, and yeah, once it's done, then it will predict it will give us some predictions, some probabilities, and also so that we can just make some predictions and see the expected number of votes. So
okay. In the meantime, we've got a new player, Greg. Bobby, you want to make the introductions?
Yeah, so I guess Dave's mentioned the Stats Insider model, which was actually built by Greg. So I don't know if you have any sort of questions about the model, or maybe some variables that you might want to create, bounce some ideas off Greg while he's here. Feel free to.
But Greg, I'm also really interested to ask you, and hello, thanks for jumping on board.
No worries. I was sort of waiting to jump on. I couldn't wait. It's really awesome to watch, to be honest.
What are you making of what's happening in front of you?
I think it's amazing. Like, we know the game so well. We know all the little things about it. And Quan is just like, trying to make this model from nowhere. And it is fantastic to watch. Some of the things, especially the positions, I thought was, pretty funny. The way we've got ruck, rover and rover, which are sort of outdated positions in our world, but that's the way they're listed in the Fitzroy package. That's the way they're written on the team sheets. To go through those things is sort of funny, but the end result is, you can only flip data so many ways. And when you go through it, it's really remarkable how close he gets to some of the other predictors going around.
What did you think when he first popped up that set of names and that so closely matched the names that everyone has got in the running?
Well, I mean, the names that popped up to me were exactly the names I expected from the variables he was using. So it wasn't that much of a surprise to see your McRae's up there and your Olivers, the guys, the disposal pigs, I call them. It wasn't that much of a surprise to see them up there. It's just funny imagining what he would have seen. These names would have just been Bobs and Dugnut or whatever, like just random names who happen to be, actual favourites are up there. So, yeah, it's really not too far off. And I'm really excited just to watch someone who has no idea just go about it. It's phenomenal, really.
Because you spent several years working on your model and refining it, haven't you?
Yeah, not building up to this one moment, but I have been watching football since 1990, so I've got a bit more experience, but I have been modelling it and producing content for it for the last 3 years, and then doing personal stuff for years before that. So, yeah, I have an idea of which variables will work and which ones won't. And I mean, the thing about the modelling that Quan's doing is that if he is throwing variables in there which are useless, the modeling's throwing them out anyway. Like, it's not like he has to know what is useful. It's throwing them out anyway. So it is coming down to those disposals and goals and things like that.
I wondered about that when he put in all the variables, and we know that some of them aren't that relevant. We don't think they are anyway. Yeah. So Quan, sorry. So Greg, you go on.
Yeah, no, it's just sort of one of those things where you could almost use all of the variables in the Fitzroy package and work your way backwards instead of trying to pick them out individually. and just let the computer throw them out as you go, you might end up with something. You will end up with your Olivers and your McRae's at the top. I mean, Oliver's a really decent chance, but I don't think you'd find McRae if you did anything besides look at total disposals. That's my opinion, although I think he'll do very well. But yeah, it is interesting.
Yeah. Quan, this is a really ideal opportunity for you to maybe ask some questions of Greg, because as he said, he's been watching the game for ages and building models for a couple of years now.
Right. So, hi, Greg. Yeah, thanks for being here.
No worries. It's actually Friday night here, so I've got a beer. So I apologise for you being up at 4 a.m.
Yeah. Yeah. So I have just some questions about like the variables that you use for your model. So like in addition to like the pure stats, did you like derive any like, ratio or like, interaction variables, or did you get data from other sources as well, or?
Yeah, so one of the main things, and the main difference between what you're doing now and what I've settled upon as something I can produce for Stats Insider is those media votes and coaches votes, which I've told David about. And those votes I've collected either manually out of newspapers or build a scraper for coaches votes, which I think Robert's done. He's built a scraper for that. And those are the things that differentiate what I would do compared to what you're doing, but you can't do anything more without that knowledge. So I only say that now as in that's the major difference. The other thing I would do that while I've been watching you that you could improve your model with is that each game is its own game. So when I look at the top four that you had of Oliver and Petrarca and McRae and Bontempelli all from the same team, I find it difficult to see those four players up the top from two teams, given that there's only 6 votes given out per game. A way you could go about that to do that is, or what I do is I essentially figure out a probability of who would get 3 votes in a game, and then I simulate from there. So a McRae might be 80% and a Bont might be 20% in a game. So we'll sim that and we'll get 3 votes for one of them, take that guy out of the pool and then sim the next one. That's one way to sort of differentiate it out that I think that you're missing. Supercoach, I saw you add Supercoach recently. I'm not sure if you've run a model with it yet, but Supercoach is a really good variable for Brownlow modeling because every AFL game, Supercoach hands out exactly the same amount of points. So it doesn't matter if it's a low-scoring game or a high-scoring game. Supercoach gives out exactly the same amount of points per player, which is really good when you're trying to figure out the 3, 2, and 1 or the best players from each game. So there's a couple of things that I've noticed.
Okay. Yeah. I actually did not use Supercoach because for 2021, all of the rows are missing for that variable. So
right.
Yeah.
I think in the Freizig, there's they're missing in there, but I don't think they're missing in the Footy Wire scrape of Fitzroy.
All right.
Yeah, they're in Footy Wire scraper, but not in the Freizig upload. So that's just more like the AFL website didn't populate it.
I think there'll be different IDs. I'm not sure Robert's the expert on Fitzroy, but it might be different player IDs though. That's the problem.
Yeah, there would be different IDs, but I guess depends on how much you want it, really.
Yeah, right. I do think that the Supercoach is far superior to, say, the AFL player ratings that you've got, only because they can give out way more than normal in a game when, each game you only get 6 votes to give out regardless.
Okay, so it seems like we got some predictions here for our second XGBoost model. So here is our variables important plot. So some of the significant predictors here are AFL fantasy score, disposals, rating points, match margin, goals kicked, contested possessions, effective disposal, and etc. So these down here are not helpful in predicting what these up here are. So Dave and Greg, do you have any thoughts on these variables?
Yeah, so with the AFL fantasy score, you could probably normalize that to an amount for each game. So because fantasy score is essentially just 3 points kicked, 3 points mark 2 points handball. So you're going to get more of them in some games. But if you normalize the AFL fantasy score for the same for each game, it can sort of be a quasi super coach in that way.
Okay.
If you can do it, I mean, but having said that, AFL fantasy score appearing at the top there as a massive weighting is a really good sign, because it is essentially added disposals and added goals and stuff like that. It's a total of them.
Yep, cool. All right. So let's see what this model predicts for the top vote getters. All right, so here's the top 10. Again, we get Oliver, Petrarca, McRae, Bontempelli, Wine. So it doesn't look to be that much different from the first model. But again, we got Oliver winning with roughly 30 votes. So if you're going to trust me and you want to go bet on it, bet on Oliver.
I mean, in all honesty, there are 6 names there which Stats Insider have in their top 10.
Yeah. It's all really plausible, isn't it? I think we still got this issue that the first 2 players are on the same team as our 3rd and 4th. And the issue that I raised before and that Greg points out is that every time Clayton Oliver gets 3 votes, he takes away the opportunity for Christian Petrarca to win 3 votes. In other words, they're taking votes off each other. And the umpires can only award 3 players votes in any given game. And that's 3 out of the 46 players who potentially played in the game this year. So that's the fly in the ointment. And again, I'm definitely not the stats man here, the data analyst, but to me, that's the anomaly, seeing those groupings.
All right.
Is that how you see it, Greg?
Yeah, I do. And I think that's where the approach of simulating each game by itself and only giving out 6 votes for each game can sort of help that problem. But having said that, I mean, it's a really good top 4 regardless.
Yeah, it really is. Yeah.
It really is. I think so. Yeah, it's just sort of getting around that problem, which I get around by just saying use 10,000 simulations of it, and then working backwards from there to get a probability. But
it's also like, I mean, what it reflects is that it's unerringly accurate in that all of those players had great years, and this is not looking at stats or anything. It's just that we as football lovers know Christian Petrarca and Clayton Oliver had exceptional years, even though they're playing on the same team. They were both outstanding. And the same with Jack McRae, was the most consistent player of the year. He was stunning. And Marcus Bontempelli was brilliant and he won games, so he was also really good. The one there that Ollie Wines is that, he was the standout player from his team, and there weren't really other players taking votes from him. So you would expect that when his team, Port Adelaide, played well and won, which they did a lot, and he had a lot of good games, that he would get a lot of 3 votes, whereas Clayton Oliver and Christian Petrarca are going to be stealing votes from each other, as are Jack McRae and Marcus Bontempelli. And I think that's one of the things that really showed up in your model, Greg, that you've got Ollie Wines on top in terms of the chances of him winning at 34.9%. And I think that was a big factor for you, wasn't it? That people aren't stealing those 3 votes from him.
Yeah, I mean, there's Travis Boak is probably the only other one at Port Adelaide that can take him off him. I think with Wines, he just ticks a lot of those boxes of he does get lots of disposals. He is in a team that doesn't steal a lot of votes from him. The team did very well. They get lots of wins. So, yeah, I mean, that's why Wines is at the top. But when we're splitting hairs between Oliver, Bontempelli and Wines for those top 3 positions, it's nothing when simulating. It's nothing. It could happen in any order.
What are you going to do next, Quan? What else could you do?
Yeah, so do we have any suggestions from like the YouTube chat or for anybody? Because I'm interested in hearing those and see if I can improve. So we might use a different set of data, because there's a Frizik, but there's also other sources that you said. So
Yeah, I mean, I guess you wouldn't have the knowledge, so you could try using the Footy Wire data set. So
Okay.
that's just like another popular AFL fan website that has heaps of stats. So
let's put it 2015, but just to speed up the prediction, I guess. Free wire that should give us something. Let me just do a check here. Is the structure of this data set the same as the Fitzroy or the
yeah, so it just has different variables. So I guess for AFL fans, mainly stats are divided between 3 websites: AFL tables, which is like what a lot of people use because it goes all the way back to the start of VFL, so over 100 years. And then Footy Wire has data from, I think, 1954. And then Frizik takes data from the AFL website. So the AFL website tends to get populated with some sort of more advanced stats when they come about, but they don't always get back populated on sites like AFL tables or Footy Wire. So I think Greg was talking about Supercoach scores. So that's just the column SC here.
Okay, so S, where is it?
SC, yeah. No, S to the left.
Yeah,
of it.
Yeah, that's it.
Yeah. All right.
Yeah. And
all right. So I mean, I don't know what these mean. So
yeah, so I think Greg or Dave can help out.
Yeah. So
Contested possessions and uncontested possessions.
got it.
What's ED?
Effective disposals.
Effective disposals. I mean, some people will say effective disposals are important, but some of the really good players get it so often that they're actually effective disposals are down, especially if you're a midfielder, which is what we're modelling. But definitely use Supercoach if you can get it from Footy Wire.
Mm-hmm.
You can get tackles inside 50, rebounds, sort of like a center clearances, intercepts, possessions.
I mean, again, too, those sorts of things too. So if disposals, like what the umpire sees, when he sees a player get the ball from a difficult situation with a lot of players around him and then kick it, that to him, you would think, or her, would suggest, well, that was a good thing in football. It's a tick. They might not necessarily look at where the ball lands or what happens after that. They see the movement, but not the outcome, because there's 3 umpires on the field, Quan, and so the ball goes from one umpire's territory to the next umpire's territory. And so that's why I think there is that query about whether effective disposals is such a good thing. But again, a contested possession or winning a clearance, the umpire sees that under his nose or her nose, and that's a big tick there for, doing something effective in the game of football.
Oh, okay.
I also think with your modelling techniques that if you did have effective disposals in there with disposals, while it sounds like it's overfitting massively, I think it would probably throw effective disposals out. It might not.
I think it in the background it does some automatic feature selection. So yeah, it probably got rid of it. So all right. This is for the okay, so I can join this. Is there a column here for Brownlow votes? Because I
can't see it.
I don't see it. So
I can't see it.
Yeah.
This is Footy Wire.
Okay. So we can join it with SC by the player.
So you could, I don't know, I was going to say fuzzy wuzzy, but it might be a Python thing. But the only 2 players in the AFL with the same name are Josh Kennedy and Sam Reid.
Okay.
Having said that, Footy Wire will call Nat Fife Nathaniel Fife and things like that.
Right.
I should just say too, just in case anyone has joined late and they're wondering what we're doing, we've got Quan in Chicago, who's never seen a game of Australian rules football, and he's trying to predict the Brownlow medal based purely on the data, the stats from this year and using the previous years as a guide. And he's been coding as he's going, and it's been absolutely fascinating. And now he's just trying to work out whether he can refine his model at all.
Yeah. Let's look at the original data again. Yeah, first name. I wish there's like a player ID column here. Well, because there's only match ID, the player name. Oh,
Yeah, it's gonna have to be a fuzzy match on player name.
yeah. I think there's a package for fuzzy join R. I've never used it before. All right, next. Misspelling. So there's some regex here. Okay. Any names here? Yes, we're going to try this package to see if we can. Is there a vignette somewhere I can look at for some tutorial? Let's try it. Okay, so join. What was the previous one? This. All right. Choose. Sure. There. So,
hey, Greg, while Quan's doing that, one of the things I wanted to ask you is how much debate is there in your community about various models and who's right and who's wrong? And because, you know, the big standout for you, we talked about this the other day when I interviewed you for a piece that's going to come out on Sundays, you don't give Jack McRae, even though he's winning votes, you don't give him a hope in hell, really, of winning the Brownlow medal, and yet he's right up there in so many other models.
Yeah, so I guess the beauty of my community, our community, is that when you talk in probabilities, there's always a chance McRae could do it.
Yeah.
Unless I said there was no chance and then he did win it, I think that would be that'd be pretty embarrassing. But I don't think it's necessarily a contest. I think most people are really interested in different ways of tackling it. I know I am.
Yeah.
And I certainly don't think that I've got the best model at all. I think I've got a model that I've worked on for a while, and I'm really interested to watch how other people do it. And I've done the same. Like, I learned from other people building models just like this, and then I put my own spin on it. So it is a community where people sort of have to help each other, because you sort of can't read about it anywhere else. They don't teach it at university how to model the Brownlow.
There's also a fair bit of intellectual property too. I mean, because you're in competition with some other, champion data and whatnot, aren't you?
Yeah, I mean, if the competition was who could build the best model, it would be. But it's not. To win the Brownlow, Tom Mitchell or Sam Walsh could win the Brownlow this year, and no one could have predicted it except for some guy who has no idea. He's just a Carlton fan. Yeah. We're not going to call him the greatest Brownlow medal predictor, are we?
Yeah.
So, I mean, from that way, it's sort of a little bit hard to measure. I know that the Betfair ran a competition last year on people's models, And I found the models that did the best were the most aggressive. The ones that said Oliver's definitely getting 3, Wines is getting 2, Truck is getting 1. Like, they're the ones that won it, because to win those sorts of competitions, you have to be really aggressive. They could finish first or last. From a modelling perspective, it's probably not the most academically satisfying way of doing it.
From a stats point of view, like the wisdom of the crowd, people, talk about the bookies odds and so on. How well do bookmakers go in terms of predicting these winners?
I'd say a lot better than people fully understand. They obviously take their 5% or more juice in markets, so they can afford to be a little bit wrong. Although with the Brownlow markets, they do go up. When they do go up, they are a little bit wrong, but they're sort of tissue prices that get pushed in by people betting them. But I would use as a benchmark the bookmakers happily, without having to do anything to do with gambling at all. It is a good benchmark. That's one thing that surprised me about the model this year, the Stats Insider model this year, is how similar we were to the bookmakers without having any idea what the bookmakers were going to put up. And that includes the Bontempelli beating McRae easily.
And that's based purely on just having a certain number of people. The more people, the better. Putting their view out there about what they think it is. Is that how bookmakers frame their odds, isn't it?
Well, not necessarily. So, bookmakers will take a stand on what they think will happen if they believe they've got more knowledge. But ultimately, they will balance the money as it comes in. So they would definitely don't want to have too much on the wrong side. And so they will move with the market. But their initial stances are done by very good modelers most of the time, sometimes not so good. And sometimes they put up what they call a tissue price, which is just, we won't accept a lot of money on this. And as little bits of money come in, we will get sharper and sharper depending on which way the money's going.
Okay.
But they obviously have the models that they have built or they started with must incorporate some form of wisdom of the crowds to not have McRae appear at the top, to not have Oliver a runaway winner, etc. So they are doing something a little bit more sophisticated than this, but they've been doing this for 20 years and longer, so they know what they're doing.
Trying to join on player name, season, and round. So round. So round. Let's go to string.
Yeah, so I guess while he's doing this, one of the kind of interesting thing I think, or maybe annoyance with AFL stats is just sort of like how scattered it is, right? So I think before we were talking about media votes, coaches votes, Footy Wire, AFL tables, the AFL website, right? So there's a lot of sort of data cleaning, joining that has to go on. And sometimes, like you might have a variable that you really want, like super coach scores or say coaches votes. And then I think this is like a pretty cool thing for people to see how you can join all these different data sets together pretty quickly.
Someone was actually pointing out on the chat too. I don't know, did you put hit outs in the original set of variables?
What is it?
Hit outs. It'll probably be an HO or something like that, because the ruckman, it's one way they can build up stats that other players can't get.
Yeah, it's probably somewhere in here. So
I think even in the Freizig, it'll have hitouts to advantage, I think.
Okay.
Yeah, I think because ruckman don't get votes, it was chucked out.
It's true. I do believe that it'll probably get chucked out as well. But So don't break your back trying to find it.
So phrase it here. So what was the name of that variable again?
Well, hit outs.
Okay. Yeah.
Hit outs,
I think I included it. So
Okay.
yeah, I can actually get rid of it right now and yeah, run it again. Hit outs. What else should I exclude? Because I can exclude some stuff here as well. So hit outs.
I think, or at least from YouTube, maybe it's not about exclusion, but more maybe creating some interesting thing and seeing if they get chucked out. So some people have suggested maybe like ratios, so like how many disposals as a percentage in the game. So would be quite interesting. Or I think someone else suggested like a rolling average of previous years, how many votes they got. Like previous 3 years, how many votes they got as like a predictor.
Okay.
Were a couple of suggestions.
I'll give you a really good suggestion. Possibly a rank for each variable that you're using per game. So instead of saying a player will get 45 disposals and the second best player will have 32, it'll just say 1 and 2. But if you do that with the really important variables, if you get Supercoach in there as well, for example, it'll have a better idea. What I found, the models will have a better idea of who is more likely to be, the top 3 players on the field, just because you're already ranking every possession or every variable as a 3-2-1.
Yep. So let's see. So we should rank everything. Got it. Yeah. So we can do it by match ID. Okay. Let's try it. All right.
Awesome.
That idea that Bobby suggested from one of the people on YouTube is interesting. And Greg, you might know something about this, but there is that perception that umpires tend to favour the players who they know are good players.
So
is that true or not?
It is true. In fact, I did a little thing using the Supercoach as a proxy. I said if you had played, I bucketed players into 10 games, 20 games, 30 games, all the way to 120 games that they had played previously. And I said if you had a player that had scored 120 Supercoach points, and then had looked at how often they got votes, it actually turned out that the more games you played, the more likely you were to get votes in seemingly an identical game. So that recognition, I used games played, how many games have they played previously, which I might assume the umpire has seen them more, knows them more, better known players as younger players. So that's how I looked at it. Although I will say that when I ran it through my model in the end, it is in there. It did throw the games played out a fair bit.
Yeah.
But on the whiteboard, games played was pretty important. And I'd use that as a proxy for recognition.
And I suppose the other thing too then would be Brownlow votes. Like if an umpire knows that a player is a good player because that player has previously got Brownlow votes, does that mean that they're more inclined to give them the votes?
I think one of the problems with using that, I mean, it's fine to give it a try, but I think one of the problems with that is that because you only get Brownlow votes at the end of every season, if you were to look back at the last 2 seasons, you might think that Lachie Neale this year we're gonna think he's really good this year, when he had the back injury and he dropped off a lot. So using that, how often have they got votes in the past metric doesn't flow well to how much they'll get in the future, as well as you'd think. But it's certainly something worth exploring. It's not worth nothing. It's not worth nothing.
Yeah, yeah. I mean, when you look at those, I mean, we got the names up before of previous Brownlow winners, and there is you see the names appearing often. You'll see Nat Fyfe. Well, he's won it a couple of times. He's been thereabouts. Patrick Dangerfield is always thereabouts. Now, unquestionably, that's because they're really good players. They're amongst the best players in the competition. But I wonder if there is also that perception when the umpires are deciding at the end of the game, whether they have some kind of unconscious bias to giving votes to a player who they know is a good player.
Absolutely. There was, I read something by Liam Lenton last year. he had looked into being a captain, and if a captain meant you get more votes. And I think from memory, his conclusion was something like just over 1% more likely to get a vote if you were the captain. So I put a little binary yes or no if you were the captain going in to have a look. And one of the models I ran, one of the ordinal logistical regression models that we ran, one I'd used last year, looked at it from this year, and the captain variable was weighted so highly, it had steel just winning easily. So I had to sort of get rid of it just because it was messing with things so much. But that, once again, that's that recognition. That's that thing that you might not find in raw statistics.
And I should make a shout out to the ABC sport editor, James Coventry, who edited a book called Footballistics, and Cody Atkinson and Sean Lawson, who write for the ABC, also helped in that. And they found that blonde players and bald players actually did pretty well in the Brownlow too. And the theory was because they get noticed.
Yeah. One thing that we haven't got in this data set, which I think I'll be trying to do next year, is guys with lots of tattoos, guys that wear helmets.
That's everyone now, though.
Guys with bald heads.
Greg, can you repeat one more time about the rank approach? So you just take all the stats and rank for each match, right?
Yeah. So the theory would be is that you would, so any year besides 2021, and besides this year, is 44 players, but essentially rank them from 1 to 44.
Yeah.
I think that just helps normalize all your statistics a bit better.
Yeah.
I guess the downside of it is you don't want to lose the difference between a 45 disposal game and a 30 disposal game, but it just will get rid of some people who are nowhere near it.
Okay. Kicks, marks. Okay. Say so you take. Sample games again. All right, so kicks. So now we have all the ranks here, but there's some ties. Would tie be an issue, or?
I don't think so. I'd ignore the ties. If two players have tied for the most kicks, that's fine. They're both number one, and the guy that comes in at third is just third.
Data now, then let's run it. So goodbye, mutate.
So I don't think you had any code to just include one single game before that. Hopefully,
I did a group by match ID, so it's just like grouping it for each match. So I'm gonna get the rank for each match here for all the columns here.
Okay.
So yeah, I think that should do it. I check it with one case here, so should work now. Let's check it with two. What do I name it? ID. Do a group by. So sample 2 games, 88. So that's for 2, 44 times 2. For the first one, I'm just write some code here, but just to inspect it. So how about this? All right. Summarize. Just a quick check. Group one. Well, I think we got it here. So So first game, that's the first 44 rows. Yep, and the second one.
I think it'll definitely be helpful for things like the AFL fantasy score, which is at the moment basically a proxy for Supercoach.
Yeah. Yep, 1 to 44. Good. Now, so 45 to, yeah, also 1 to 44. All right, cool. Yeah. So let's run it. All right, good. Okay, so we get all of those. So, add this to this. Where is it? Should do it. Cool. All right, so I'm gonna run all of these again. Pred. Let's actually see how long this is going to take us this time. All right, so caboose here. Yeah, so again, if you're just tuning in, the previous prediction we got were Clayton Oliver as with 30 votes as the winner, followed by Christian Petrarca with 26 as a runner-up, and Jack McRae, Mark Spontapelli, Ollie Wines. Those are the top 5 vote getters that my model predicted. So this is an XGBoost model. So I'm running it again. So this time I'm using Greg's suggestion. I'm using all the ranks of the statistics instead of the pure stats. So range 2015. Okay, yeah.
One thing that might be worth checking, if possible, is to see just on fixing the model, is seeing how many votes it is suggesting per game.
Okay.
Because there might be some games where it's suggesting only 4, somewhere it might be over, and that's when you know your model is going to be way off because you've got to give 6 every game.
Yeah.
It doesn't have to be exact. I mean, well, preferably it does, but it would really help with normalizing everything if it is giving out 6 votes per game.
Yep. Okay.
Yeah, so it'd be interesting to apply this model to a previous year to see how closely it correlates with what actually happened.
Yeah.
It would definitely have Tom Mitchell winning.
Yeah, that's good. And Lockie Neal.
Yeah, Lockie Neal for sure would have last year's winner.
But the Nat Fyfe ones are the interesting ones because he wasn't really a big possession winner, was he?
No, because he has that ability to go forward, so he doesn't have to necessarily just sit in the midfield like the others.
Yeah. But that's why I think that the Jack Macrae one's really interesting too, because the difference between a player like Nat Fyfe when he is really on song, he's really winning games. He's doing things that are winning games. He's going forward. He's taking big marks. He's kicking goals. Where Jack Macrae is just getting the ball a lot and delivering a lot of 20-metre passes and things like that, which is still incredibly effective, but not as eye-catching in the way that Nat Fyfe, you feel when he's having a great game, can do as much with a 20-possession game than Jack Macrae might be doing with a 30 or 35-possession game.
I think the Bontempelli versus Macrae this year will be a really good example of that.
Yep.
Just straight up, two guys from the same team. One is more favoured than the other one to do well. The other one gets more disposals than the other one.
Although I was actually surprised by how many disposals Bontempelli actually did get. I mean, he's ranked 10th. I mean, he's still almost he's 180 odd behind Jack Macrae, but he's in the group with the rest of them. Macrae was just such a standout in terms of possessions. But you're right, it's that get the ball from the centre, run 15 metres, kick a goal, that sort of thing just catches the attention so much more than just getting the ball right and chipping it 20 metres or so.
Right. And traditionally, Bontempelli has somewhat underpolled at the Brownlow compared to what media votes have given him.
Yeah.
And coaches' votes, those sorts of things. He actually has underpolled with the umpires. So this year I feel like him being the captain, being in a good team, it sort of has that changed. Has he turned into a Fyfe collector of votes?
Yeah.
That's sort of what I'm eager to see. Otherwise, in the past, they have gone for your Macrae's. So it is interesting. The other really big one is that Nick Naitanui tends to be someone that I constantly over-predict the media votes, and his impact in games is something that, for me, comes out really high. And then when it comes to Brownlow night, he doesn't.
Champion Data's number one ranked player.
Yeah. And I mean, he's this 7-foot ruckman with long hair. How do the umpires not see him? He gets all the clearances. But
that's right. And when you watch him on a good game and he wins those taps, and they are genuine taps to advantages, or he gets his own clearance, it's so dynamic. I agree. I mean, in some senses, as a ruckman, you would say he had the most standout games for ruckman. When you watch a game and say, well, he won it, or he did something extraordinary that game that you might not see as much from Grundy or even Gawn.
Right. And I think in the back of my mind, I think one of the reasons why Nick Nat is overlooked, in my suspicions, are that the umpires do look at the scoreboard at quarter time, half time, 3/4 time, and they do in their head take in the possessions. And when you have to vote at the end of the game, even though you might not be just saying, I'm just going to give it to the most disposals, you do think back to, what have I missed? On the scoreboard it had Gaff, or it had Sheed or Redden at 30 disposals, Nick Nat only on 15. And I think if you put yourself in as an umpire, as a human, you might take the easy way out just so, you're not hanging yourself out there on Brownlow night.
Although they do have to discuss it. I mean, there's 3 of them, right? So they've got to reach a consensus, don't they?
Right. So they do a little bit of a small wisdom of the crowd. It's just the 3 of them right there and then they do it.
Yeah.
I'd be keen to know if one umpire does just dominate, like there is an alpha umpire that says we'll go this way or not. But in theory, it should be 3 individuals making the decision.
Yeah. But they have to reach that decision by consensus. They don't all vote and then combine those votes. They have to make an agreement.
Right. Yeah, that's where the power structure of the conversation.
Fascinating to know.
Yeah.
I don't suppose there's any AFL umpires on the 60 odd people who are watching this YouTube feed at the moment. But if you are, chime in.
I might duck out. I've got someone over here, guys. But I will be listening in the background. I will come back, but I won't join the stream. So
thanks for your input, Greg. It's been great.
No worries. I wish you good luck finishing it off. We'll see how this model goes, and good luck on Sunday night. See you guys.
Cheers, Greg.
All right, so I think this model is done, and so I'm currently looking at the variables importance. So it's still the familiar stats that we got from previous models. So fantasy score, disposal rating, points, goals, score involvement, margin, effective disposals, kicks, contested possessions, shots at goals. So
you've got disposals there and kicks and handballs. Remember, disposals are a combination of kicks and handballs.
Right. So maybe in the future I could try some sort of dimensional reduction where I can combine these two into like one.
Be better off, I think, getting rid of disposals and just having kicks and handballs.
Okay.
Because essentially what you're doing is doubling up.
Although, I mean, this is a prediction problem, so that's a problem of multi-collinearity. But if it's give us like a big prediction, all we care about is the prediction. So I guess multi-collinearity in a prediction setting would not be too much of a concern. Still running. Oops. Can't cover. XG fit final. See, got some variable issues here. Double to integer. Okay. Try to fix it.
So, Bobby, where are you with the disposals thing? Is it better to have disposals as one, or to separate it out, have kicks and handballs and do away with disposals?
Yeah, I'd probably have maybe just disposals instead of kicks and handballs. I guess if I was to include kicks and handballs, maybe I try something like a kick to handball ratio.
Okay.
Instead.
See if this will do it. Cannot convert from kicks to kicks. Double the integer due to lost position. Gotta do something with the rights here. Let's see, how do I fix this? I think I got it the wrong order. Signature, so let's convert this. So can't convert that to works. Whoops. This model doesn't look good. So we got like a total votes of like 65, which is like too big. So yeah.
That's okay. I'm sort of bit conscious of the time where you are. I guess we did get you up at 3 a.m, and it is sort of 5:30. How about can you just maybe let everyone know who's watching your GitHub? Maybe you can upload this and obviously sleep, and then maybe when you get up in the morning, just email your predictions through, and for those watching and those interested, read about it on abc.com.au.
abc.net.au. Sunday morning, we'll have it up there.
And you can read your very own Brownlow prediction and see how it goes that night.
Sounds good.
All right. I'm just very impressed. So impressive, and not only for getting up at 2 o'clock in the morning after 3 hours sleep and doing all this, but just from the very first, you got it. You know, your first hit looks spot on. So be really interested to see what your final prediction is, and and at least you can know for right now that you're in the ballpark with all the other models that are predicting winners too, including the human ones.
Yeah, and I'll say some of the suggestions from YouTube as well, because obviously you didn't get a chance to look at that.
Sure.
Yeah.
But thanks so much.
Yeah, I just want to thank everyone. Just want to thank Bobby for having me here, doing this, giving me this opportunity to do some live coding. This is good practice for me as well. Just want to thank Greg and David for all the suggestions, all the questions, and all of the explanations about, this sports, something that I've never seen before. But I'm planning on checking out like maybe a game sometime soon. So
grand finals in a week. That should be a good game to watch. It's your first one.
Yep.
Definitely a good game to watch, and you've got 4 of the best players that you've already picked out will be playing in that game. So, you're on the money. Great job.
All right. Thank you.
Thanks, Quan. Thanks, Bobby.
Cool. So thanks for everyone for watching. Read about it on Sunday and see the final predictions. Hey, get excited.
All right.